Hey there, my name is Majid and you're super welcome on my brand new channel about Swift development. Today we're going to talk about parallax effect and we'll try to implement it in SwiftUI. If you are not familiar with the parallax, take a look at the Xcode preview. Here we have the scroll view with the image header and text below. When I try to scroll it, the text overlaps the image because they move at a different scrolling speed. As you can see, image also has this nice scaling effect when I drag the text to the bottom. And we'll try to implement it in SwiftUI. Let me switch to the actual code. So right now our Xcode preview shows the code in the code editor where we have the scroll view with the image and text below. And as you can see, when I try to scroll it, they move together with the equal speed. Let's start by embedding our image header into Parallax header view, which is a regular SwiftUI view I will define right now. And as you can see, we embed our image using the closure. To achieve that, we define view builder closure in the Parallax header, returning content, which is a generic label for another regular SwiftUI view that we will put inside the header. Now we can define our body property where we can put the content closure. As you can see, we fixed all the issues in the Xcode and now our previews are working, but it's still the same regular scroll view. How we can achieve that overlapping effect? To do that, we need to understand the content offset of the scroll view and add it as negative offset to the parallax header to compensate somehow movement and slow down it in general. So we can do that by using GeometryReader because GeometryReader allows us to read the parent size, but it also allows us to read the frame in the global coordinate space. So for example, if we will embed our parallax header in the GeometryReader, whenever the user scrolls the scroll view and our parallax header moves outside of the bounding box of the scroll view, GeometryReader's frame will change. And we can calculate the offset by using top Y position of the GeometryReader. So let's embed our content into GeometryReader. As you can see now, we have some alignment issues in the preview. Let's fix that by using frame view modifier on our content and fill it inside the GeometryReader by using the same width and height. Now let's calculate the scroll offset by introducing mean Y property and use geometry frame function in global coordinate space and mean Y value. Now we can add the negative offset to the parallax header to compensate moving speed, and let's make it negative and multiply it by 0.8 to slow down a little bit. As you can see now, our text overlaps the image because they have different scrolling speed. But the image doesn't have that nice scaling effect when we drag the text to the bottom. Let's add height to our content by adding mean Y. And in this case, as you can see, our image has this nice scaling effect when we drag the text to the bottom, but it also shrinks when we move the text to the up. Let's eliminate negative values of mean Y by using max function, and let's try it. Okay, it looks great. Yeah. Now the max function eliminates all the negative values, and we have this nice scaling effect when we drag the text to the bottom, but it eliminates shrinking. And that's it. I hope you enjoyed the video. Feel free to press subscribe button to never miss another one. See ya!